Good morning. It's really cold out, so I thought it'd be a good time to put out another video. Today we're going to be looking at equivalent fractions. So what we will start with is a definition of an equivalent fraction. Okay, so let's start with the most basic of fractions. We're going to start with fraction 1/2. When we're talking about an equivalent fraction, what we're really saying is we're taking an object or a group of objects, we're dividing them into fractions, but then when we want to split that fraction up some more and yet still give somebody the same amount they would have had, we would find an equivalent fraction. So if we think of 1/2, we'll take our disk and we'll, of course, cut it in half, and we're talking about using 1/2 of it. So that's the fraction 1/2. An equivalent fraction would say, we're going to find a fraction that will still allow us to give the person who's getting this 1/2 of the object the same amount they would have gotten, and yet divide the entire object up into more pieces. Now that doesn't mean we can just pick any fraction we want. For example, if I want to say cut this into thirds, the problem would be that to divide this object into thirds, as we will do with our dotted line right now, well, within reason we will, that you'll notice right away that thirds does not provide for that same amount of half that that person was going to be getting originally. And I'm seeing that's not really showing up well. We'll darken that a little. If this is a third, you'll notice there's no pieces where the person who was supposed to get half of this object is going to get half the object. So we can't just pick any fraction and say, oh, there, that's an equivalent. No, what an equivalent fraction does is the equivalent fraction says we're only going to be able to choose denominators that will still allow that 1/2 that we started with to still exist. So equivalent fraction of 1/2 has to be able to actually have parts that will still equal 1/2. So as we start to look at possibilities, what we really look at is, all right, if I have to still be able to have this half, I can only have denominators that show that. So thirds we already looked at doesn't work, but if we say break the object into fourths, you can see right away the person who's going to get half of whatever this group was is still getting their half. The only difference is now instead of getting it in one large piece, they're going to get it in one piece, two pieces. But they're still getting the same value. And that's really where equivalent fractions come into play. You are not changing the value of the numerators per se, the value of what's being given away. What you are changing, though, is the number of pieces they're broken into. The larger the equivalent fraction gets, the smaller the pieces will be. Fifths won't allow me to go into a half piece for someone, but sixths will. So as we keep going, the pieces are going to get smaller and smaller, and it's going to take more of these pieces in order to keep giving the person 1/2. Well, let's take a look at the fourth. In order to get this fourth, we actually cut our pieces into two. In other words, we've doubled our number of pieces. Well, when we say we've doubled something, what we're really saying is we've multiplied them by 2. Now, if you look, not only did I multiply the number of all the pieces, the denominator, by 2, but also my numerator, the pieces you are getting from this yourself, have also doubled. And this is when we always hear the kids being told, oh, to find an equivalent fraction, whatever you do to the bottom, you must do to the top. Well, what we're really saying is, if I've doubled the denominator, I've also doubled the number of pieces in the numerator. And we can express that by taking our 1/2 so that we don't have to draw this picture every time. And what we're really saying is we multiply the numerator and the denominator both by 2. And now, rather than my object being 1/2, it's the equivalent fraction to 1/2, which is 2/4. Let's take a look at what we could do if, for example, we needed to find a bigger equivalent fraction for this. Okay, this time we're not going to divide our object into fourths, but actually we're going to see if we could instead divide it into a fraction where to get your half that you were supposed to get, you actually are going to get 3 pieces. Well, if right away I say I want them to get 3 pieces, and they will be smaller pieces, well, that means I'm multiplying my object by 3. So now, instead of getting your half piece, that 1/2 piece, you want 3 small pieces. Well, if we divide your half into thirds, you'll see right away that now you have 1, 2, 3 pieces. But here's the thing. Anything I do to that side of the fraction object, I need to also do to the other side. So if I divided this side into thirds, that means I also divided the entire object that way. So if there are 3 on this side, to keep it all equal, equivalent, equal, we have to also divide the other side the same way. And when I do that, what we end up with is no longer 2 pieces, but if we count them, actually 1, 2, 3, 4, 5, 6. 6 pieces total, because remember we said the denominator shows when one whole object or one whole group, how many pieces it's divided into totally. And then I have 3 pieces that we are actually giving to someone. The 3 that we are using on our numerator is 3 6. Now that person is still getting the same amount they would have gotten, and hence the name equivalent. You're getting it in a different way, but you're still getting that half. It's kind of like we do with our money. Let's say I give you a dollar bill. You have one whole dollar bill. I can also give you 2 50-cent pieces. Now I've changed the number of pieces I'm giving you, but you're still getting a dollar bill. How about 4 quarters? I can give you 4 quarters. That's the equivalent of $1. You're still getting $1, but you're getting it in a different way. And that's really what's happening with equivalent fractions. I can give you a dime, 10 dimes, but you're still getting $1. I can give you pennies. You get 100 of them, but you're still getting your dollar. The difference is the values of each piece is getting smaller. With the 50-cent piece, that's half the value of that dollar. So you're getting 2 pieces, but each piece is smaller than that original dollar. Yet when I put them together, you get the whole dollar anyways. And that's essentially what equivalent fractions are doing. To get this equivalent fraction, what we're really saying is, if we want to show it as a multiplication problem, 1/2, I divided the numerator into 3 parts, and I divided the denominator into 3 parts, for a final equivalent fraction of 3 6. Now, what's unique about the equivalence is there's actually, for any one fraction, there's an infinite number of possible equivalent fractions. Let's take 2/3, for example, because I don't want you just thinking this works with 1/2. If I have 2/3, I have an object that's divided into 3 parts, and I'm using 2 of them. I can find equivalent fractions by starting to divide that object up. Let's say I double the number of pieces. So in other words, I cut every piece in that object in half. Well, that is doubling the number of pieces, so it's times 2, and I multiply both the numerator and the denominator, for which I get 4 6. If I want to triple the number of pieces, I go back to my original fraction, 2/3, and that is 6 9ths. If I want to divide them into fourths, I want to make 4 times as many pieces. 4 times 2 is 8. 4 times 3 is 12. And this can go on forever. But each time, the pieces are going to get smaller and smaller and smaller. Next, we're going to be looking at simplest form. In other words, we're going to look at how you can take fractions and rather than going larger numbers with them, actually divide and create smaller numbers but larger pieces. And with simplest form, we'll be looking at actually the smallest the fraction can get. For example, here, 2/3 is the bottom. I cannot reduce this down anymore. This one is the one in simplest form. So that is our next video.